Okay, so in this section, we're going to look at graphical limits, and you should have this handout or you should be able to print it out off of Canvas. So we're going to look at a couple of problems off of this, and then we're going to look at some limit properties and stuff like that. So we're just going to look at a couple of these. We're going to look at number 2, and I may tell you to try number 1 or something like that in the Nearpod for your kind of progress check type things as you're watching the video. But anyway, we're going to work through all this. We're going to kind of ignore E and F on all of these. I may talk about them a little bit, but we're not doing the limits as x goes to positive and negative infinity with this. So we'll talk about that later on when we do limits as x goes to infinity, but we're not doing those right now. So anyway, A, limit as x goes to 2 with this is a little negative of f of x. So that means, okay, we're looking at x equals 2. So we're looking right in here. And we want the left-hand side. So we are looking at what is happening maybe as we go from 1 to 2 on our function. So as we come in from, actually, let me get a different color. As we come in from 1 to 2 right here, what is happening to our y values? So our y values are going from probably about 1 all and going up, 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 and they stop at 2. Okay, so as our x values get closer and closer to 2 on the left-hand side, what are our y values doing? That's what you want to ask yourself when you're looking at a graph. If we were to make a table, we'd do 1.9, 1.99, 1.999, and we get these y values, and those y values would be getting closer and closer to 2. So this one is equal to 2. This one, B, is doing the limit as x goes to 2 with a little plus. So that is the right-hand side from greater than 2. And so again, we're going from 3 to 2 and as our x values, and we're looking at the corresponding y values, and we see as we do this, we're getting closer and closer and closer down. It starts here at about 1 maybe-ish, and it goes down, down, down to 0. So this is 0. So again, the answers to these are y values. All right, our x values, we're looking at getting closer and closer to 2 because that's the number right here. All right, that's the number right here. But our answer is a y value at that point. Okay, so on the left, it's 2. On the right, it's 0. And so C is easy. All of these, C is easy. You look at A and B. If they are the same, then C is whatever that number is. In our case, A and B are different. One is 2, one is 0. So since they are not the same, we have to say does not exist. All right, so this one, really you are looking at A and B to tell you the answer to C. D, f of 2. So f of 2 is different. There's no limit. All right, remember the limit is what's happening around the point, not at the point. So for the limit, we don't care that this is a closed-in dot and that's an open dot. We could care less about that. All right, so the dots don't matter for limits. However, for f of 2, that's where the dots matter because f of 2 is asking you what's the y value when x is 2. So here's x equals 2. My y value when x is 2 is 2. All right, and then we don't care about e and f. Okay, so let's look at another one. Let's look at 4. All right, so for the function g graphs below, let's find these. So all of these are x is going to 0. We're ignoring e and f again. We don't care about those. All right, so as x is going to 0. All right, so here's x equals 0, it's the y-axis. A is the limit from the left. All right, so we're going from -1 to 0. Those are the y values we're covering, and we're looking at what the x values are doing. So we kind of go up to our function, and we travel along our curve. We're looking at what the y values are doing, and as we go, our x values go from -1 to 0. Our y values are going up to 3. All right, and then the same thing from the right. We're going to start maybe at 1. Oops, I didn't draw that very straight. And we're going to take and we're going to travel along and go as x goes to 0. What's happening to our y values? They are also going to 3. All right, and then C, you're looking at A and B. A is 3, B is 3, so C has to be 3. All right, and then D, g of 0. G of 0 is asking what's the y value when x is 0. So we go to our graph, we go x is 0, we go up to the graph, oh, it's 3. right? If your graph is continuous, which means you don't have to pick up your pencil to draw it, all four of these should be the same. If your graph is discontinuous, which means you have to pick up your pencil to draw it, they may not. In fact, they probably won't be all the same. All right, let's look at one more. Actually, we might look at a couple more. I don't remember what's on the second page. For the function f graph below, find these. So again, we're ignoring e and f. We're looking at x goes to 3, of course. This is our interesting piece of the graph right here. All right, from the left, so we're maybe starting at 2, go up to our graph, and we follow our y values as x gets closer and closer to 3. So as x gets closer and closer to 3, our y values are going to 2. Again, the limit is what's happening, oops, not 3, 2. Our limit is what's happening around the point, not at the point, so we could care less about this dot up here. We care about what the line is doing. All right, with the plus, we're going to start at 4. Here's our, x equals 4, and we're going to go into 3. We're going to travel along the line, and we're going to see what are the y values doing. So as we get closer and closer in here, the y values are going also to 2. All right, C is a no-brainer. We look at A and B. A and B are both 2, so C has to be 2. And then D. So D is where the dot matters. All right, limits dot don't matter. Dots don't matter. D, no limit, dots matter. So f of 3 is asking us what's the y value in x is 3. So we use x is 3. Nope, there's no point there. Oh, there's the point. It's 3. Okay, so that's how the limit is different from the function value. Okay, let's see. Those are asymptotes, so that's not as interesting. Let's look at 9, I guess. Okay, for the function f graphed below, so same directions, we don't care about those. We're going to 0, so our portion of interest is right here. A is coming from the left, so we might start at -1, travel in, oh, looks like it's going to 1. Maybe from the right, we start at 1, here's 1, and we travel into 0, and whoa, these are getting really negative. We aren't settling down at a value. They're just getting more and more negative. So you could say negative infinity for this. You could also say does not exist. All right, this is an asymptote. All right, and so C, these do not agree. So this one has to be does not exist. You can't say infinity for this one either. And then f of 0 doesn't exist because if you look when x is 0, this is an open dot, and then as you go down, it never hits 0. So this also does not exist. Okay, and then let's look at 12. Consider the function f graph below. For what values of x0 does that limit not exist? All right, it's not going to exist at the asymptote right here. So we're going to say x equals 1, 2, 3, 4, 5, 6, -6. It does exist here because the lines are going to the same place. And it does not exist here because our lines are going to opposite places. So that's going to be x equals 3. All right, so the two sides would be going to opposite values for that. So just really quickly with this, before we get into the properties of limits, 3 times limits do not exist. We've kind of seen this on the graphs. The first is a jump, where the limit from the right and left do not agree. So this is an example of that. The first problem that we did, number 2, was an example of that. The second one is an asymptote. The limit equals plus or minus infinity. It's okay to say that the limit equals plus or minus infinity like I did up here. That's okay to say, but technically that's how it doesn't exist. It's not that it exists, it's how it doesn't exist. And then 3, we saw in the table with sine of 1 over x in the last notes, a crazy oscillation where your function never settles down to a value. That's going to be how your limit doesn't exist.